This is 11.2 statistics, contingency table test of independence and homogeneity. This is for question 2, 3, and 4. We do question 2 and 3 in this video. So you had to conduct a hypothesis testing and provide the sampling distribution, test statistic, p-value, critical value, and state the conclusion. So the sampling distribution for this chapter 11 is going to be a chi-square distribution. So that is that's the easy 1 point in your test. So the test statistic, p-value, and critical value will be found using your R. So this question 2 is asking for Lipitor is a trade name of a drug, atorvastatin, which is used to reduce cholesterol. So adverse reactions have been studied in clinical trials, and the table below summarizes results for infections in patients from different treatment groups. Use of 0.01 significant levels to test the claim that getting an infection is independent of a treatment. So this is your claim statement here, and the big keyword here is independent. So make sure, usually this is not underlined in your test, so make sure you guys, or your homework, make sure you know that we are doing tests of independence in this case. And then if we have a question, does the atorvastatin treatment appear to have an effect on infections? So if you look at it, we have a placebo, we got a 10 milligram, 40 milligram, 80 milligrams, and these are infections, no infections. These are the data. This is called observed frequency or observed values. This is doing a hypothesis testing. You have to go through all 7 steps here. So the first step is to check the requirements. So the first requirement is simple random sample. Unfortunately, there is no word of simple random sample in this case, so no. So if one's no means the requirements is not met, but let's go on to check for the other 2. Contingency table, yes, this is already in a contingency table. This is what we call contingency table. Next is a expected frequency is more than or equals to 5, at least 5 in this case. So we had to check this, we had to build an expected frequency here. So again, how do you build an expected frequency? You have to find the total of your columns. So you have to add all this number up. So this will give me 270, 863, 79, 94. And then you have to add all the columns, the row columns, a row total up. So if you add all these numbers, you get 131. And if you add all these row numbers, you get 1175. And now if you add the row totals, you get a grand total of 1306. So in order for us to find the expected frequency, you have to take the column total 270 times a row total 131 divided by 1306. So if you take 270 times 131 divided by 1306 using your calculator or your R, you will get 27.08. And you do the same thing for placebo with no infection. 270 times 1175 divided by 1306, so that will give us 242.92. And then for 10 milligrams infections, we do 863 times 131 divided by 1306. So that will give us 86.57. Okay, 56 actually. So forget my 6 there. And then usually around 2 decimal places is what I want you guys to do. 10 milligrams with no infections, 863 times 1175 divided by 1306. That will give me 776.44. And then for 4 milligrams with infections, you take 79 times 131 divided by 1306. That will give me 7.92. And then for 40 milligrams or no infections is 79 times 1175 divided by 1306. So that will give me 71.08. And then the last 2 is 80 milligrams with infections, 894 times 131 divided by 1306. Is 81 point, is going to be 9.43. And lastly, 80 milligrams with no infections, 94 times 1175 divided by 1306, you'll get 84.57. And this is what we mean by the third requirement is every single one of these has to be at least 5, which in this case is true. And then step 2 is a hypothesis statement. The hypothesis statements usually come from the claim statement. Since the claim statement says that it's getting infections is independent of a treatment, so that means that is your H0. The infections is independent to the treatment. That's your claim statement. And for the alternative, the infection is depending of the treatment. So that's why in this case, you use one for independent and one for dependent. And then the sampling, this is step 2. Step 3 is the sampling distribution. So the sampling distribution in this case is chi-square distribution. Step 4, you have to use your R. So in order for you to, again, you need matrix. So in order for us to put the matrix, you have to read your data down. So you do not use this data at all. You use the data given in the question, the contingency table, the observed frequency. So you start with 27, and then you have to read down. So 27, 243, and then you go over 89, 77, 4, 8, 71, 7, and 87. And how many columns do we have? In this case, we got 4 columns. So n columns equals to 4. So this is what happens when you type this into your R, and then you hit X, enter. Just double check this table is matched with the table in the question. If it's not matched, means that something is wrong. You have to fix it. I recommend that most people make mistake here is because you should they read the data across. You should read it downwards. Okay, and then you do the chi-square test. X correct equals to false. You will get your chi-square, which is 0.773. Degree of freedom is 3, and the p-value is 0.856. This is all in here. And now we need to find a critical value, which is q chi-square 1 minus alpha, which is 0.01, 3, and using R is 11.34. And then now we look at your p-value, which is really big, 0.856, and the alpha in this case is 1%, 0.01 is given us over here. So that's why it is p-value is greater than alpha. You fail to reject the null hypothesis. So that is not sufficient evidence to warrant rejection. So this is usually how we do when you fail the reject, not sufficient to warrant rejection of a claim, and the claim really states that the infections are independent in this case. So what is telling us that if you make this conclusion is telling us that the infection is independent because of the word not and the word warrant rejection are kind of double negation here. So you can this kind of a 2 negative become positive. So that's why it become the infection here is independent. And the last statement, question 7, is asking us that this treatment appears to have an effect on infections. If you say it's independent, so it's no effect. So since the conclusion state it is independent because it's 2 negation here, so it's independent. So that means this treatment has no effects on the infections. So that means that if you're talking about this what we call as a limiter. The limiter has nothing to do with either you have infections or no infections on this case. Question 3, a randomized control trial was designed to compare the effectiveness of splinting versus surgery in treatment of carpal tunnel syndrome. These are the results given to us. Use a 0.01 significant level to test the claim that success is independent than the type of treatments. So again, this is the independent. So we are doing hypothesis test of independence here. And then we have a question, what do the results suggest about the treatment? So this question is exactly the same questions as what we did in previous question here. In question 7, asking about question, either you have effect or no effect in this case. So this is the contingency table given to us. So the first question is asking us that is this a simple random sample? Since it's a randomized control, so it is a random sample. It does have a contingency table. And now we have to figure out, do we have at least 5 for the expected frequency? Again, how do we do this is we have to total up. So total your column, 60 plus 67, you get 127. Total this, you get 29. Total your row, you get 83 and 73. And then you find the grand total, which is 156. And then you do the same thing, finding your expected frequency. If you want to figure out the successful for the splint, you have to take the 127 times 83 divided by 156. So if you use a calculator, you will get 67.57. And then you do the one successful using surgery, 127 times 73 divided by 157, you will get 59.43. Not successful for splint, you take 29 times 83 divided by 156, you get 15.43. And not successful using surgery is 29 times 73 divided by 156, you get 13.57. Again, this is all pretty easy calculation here. And all this expected frequency that you figure out here is greater than 5. So in this case, it does fulfill the requirement number 3. Your hypothesis testing is asking, since the question is asking that the claim is success is the success is independent of the types of treatments. So so your null hypothesis is telling us that the success is independent, so that is always independent. That's your claim statement for this case, of the type of treatments that we have. And alternative hypothesis is the success is dependent of the type of treatments that they have. So make sure that this, again, I'm not underlining this in your test, so make sure you guys know this is a test of independence here. Sample distribution, step 3 is chi-square distribution. Step 4, you have to put this matrix into your R. So in order for you to read, again, do not read the expected frequency, read the one from the observed. So it's 60, 67, 23, and 6. And we have 2 columns in this case. So you do the matrix C, 60, 67, 23, 6 with 2 columns, and this is what you'll get. And if you hit X again, you just want to figure out if this matrix that you found is exactly the same as the contingency table given in the question. If you got it same, you move on. Otherwise, you have to change your numbers and your columns. Chi-square test, X correct equals to false, and this is your Pearson chi-square test. Again, class, this is what you have to give it to me in your test. These worth points, like the one I told you, the matrix and the chi-square, these are all worth points, and your critical value. Yes, I will ask critical value in this case. So make sure you guys know that these are all worth a point each. So make sure you guys know what to do here. Otherwise, you will lose quite a lot of points, although you understand these 7 steps hypothesis testing. So it came out that your test statistic is your chi-square, which is 9.75 with a p-value of 0.0018. The degree of freedom here is 1 because you only get 2 minus 1 for your column and 2 minus 1 for your row. So 1 times 1 is 1. Using your chi-square distribution to find the critical value is q chi-square of 1 minus alpha. Alpha in this case is 0.01. And then your degree of freedom here is 1. Using your R, you get 6.635. Decision, since your p-value is less than alpha, this number is less than 0.01, we will reject your null hypothesis. So when you reject your null hypothesis, there is sufficient evidence to warrant rejection of the claim that the success is independent than the types of treatments they have. So when you write this, means that you are taking your H1, means that this is actually is dependent. So how do you answer this question? Is the result what do your results suggest about treating carpal tunnel syndrome? So in this case, since the conclusion states this is not independent, means they are dependent, then the treatments appear to have an effect. So this means that it has an effect on the treatment to treating carpal tunnel syndrome. So so make sure you guys understand when you're answering questions, if it's independent, no effects. If it's a dependent, there is an effect. Okay, so this is how we do chapter 11.2 tests for independence.